Okay, good afternoon, madam. Our resource person have joined, so I am going to introduce about ma'am. Dr. Sriparna Saha received the MTech and PhD degrees in computer science from ISI Kolkata, India in 2005 and 2011, respectively. She is currently an associate professor in the Department of Computer Science and Engineering, IIT Patna, India. She is the author of a book published by Springer Verlet. She has authored or co-authored more than 450 papers. Her current research interests include natural language processing, machine learning, deep learning, multi-objective optimization, and biomedical information extraction. Her H index is 55 and total citation count of her paper is 15,971 according to Google Scholar. She is also a senior member of IEEE, ACM, Fellow of IIT, UK, IET. She is a recipient of LT Rasi Roy Memorial Gold Medal from ISI for outstanding performance in MTech Computer Science. She is a recipient of the Google India Women in Engineering Award 2008. INSA Young Associate 2024, INSA Distinguished Lecture Fellow 2025, Nasi Young Scientist Platinum Jubilee Award 2016, Bird Award 2016, I Young Engineers Award 2016, Sub Women in Excellence Award 2018, Pattern Recognition Associate Editor Award 2023, Sub Early Career Research Award 2018, Young Faculty Research Fellowship under Visaya PhD Scheme for Electronics and IT, Jan 2019 to Jan 2024. She is the recipient of Fulbright Nehru Academic and Professional Excellence Fellowship 2025, Humboldt Research Fellowship, Indo-US Fellowship for Women in STEM with STEM Women Overseas Fellowship Program 2080, and CNRS Fellowship. She won the Best Paper Awards in Icon NIP 2023, IJCN LAP AACL 2023, Clinical NLP Workshop of Coding 2016, IEEE Indicon 2015, International Conferences on Advances in Computing, Communications and Informatics. She is currently Associate Editor of several prestigious journals like IEEE Transaction on Computational Social System, IEEE ACM Transaction on Computational Biology and Bioinformatics, IEEE Internet of Computing, Neurocomputing, Expert Systems with Application, Pattern Recognition Letter, ACM Transaction on Asian Low Resource Language Information Processing, etc. Her name is included in the top 2% of scientists of their main subfield discipline, artificial intelligence and image processing, across those that have been published at least 5 papers. A survey conducted by Stonefield University for consecutive 6 years. More. So, okay, madam. Thank you, madam, for
Yeah, thank you very much.
handed over to you, madam. Please, ma'am.
Yeah,
You may proceed,
I hope
madam.
I am audible, no?
Yes, madam. Yes, madam. Audible,
Yeah,
ma'am.
thank you very much, Gripji, for inviting me in this FDP. So, yeah, so I will be talking about some of our recent works on generative AI and their applications in healthcare. So, as already introduced, I am Dr. Sriparna Shah, currently an associate professor in the Department of Computer Science and Engineering, IIT Patna. So you can also visit my webpage www.iitp.ac.in tilde Sriparna. And as a part of our research, we are also building many resources, mostly focusing on the Indian languages. And those resources are also available in my webpage www.iitp.ac.in tilde Sriparna/resources.html. So yeah, so basically, and you can also visit my webpage and you can download those resources and you can utilize them for your research purpose. So let me start with the introduction of the concept of multimodality. So multimodality is a very important concept. So multimodality is a very important concept, And multimodality, is basically is a very important concept. And in our real life, we see many, and the data is becoming multimodal nowadays. So if you see our experience of the world, whenever we see any object in real life, we have multiple sensors in our body. Like we can see the object, we can hear the sound of the object, we can feel the texture of the object, we can smell the odors of the object, we can taste the flavors of the object. So by using multiple sensors of our body, we can collect information about the same object, and then we can take a decision about the object. So this is basically called the multimodal information processing, where we are not relying on a single source of information. Rather, we are collecting information from multiple sources, and then we are amalgamating information from these multiple sources, and then it is helping us in taking a decision. So multimodal information processing is basically that is the basically the main summary, that you should not rely on only a single source of information. Rather, whenever there is a particular task in hand, you try to extract information from different sources. These sources could be text modality, or it could be image modality, or it could be video or the audio modalities. Okay, so depending on the task in hand, you need to define different modalities. And obviously, this multimodal information processing generally provides better result than the unimodal information processing, because in multimodal information processing, maybe one modality is not important, but the other modality may give you much important clue or much important information, and that way they are complementary to each other. So basically, and this is the complementary nature. In this particular slide, I am trying to motivate you why we should use multimodal information and the complementary nature of the multimodal information. So if you see the text and the image, these two modalities, and if you see the abstract concepts like the love, affection, independence, these are called the abstract concepts. And these abstract concepts can be better described using text. But how a piano looks like, if I will ask you to describe using text, maybe you will not be able to describe this using text. But image is a suitable modality to describe the how a piano looks like. So text and image are two important modalities, and we often describe some concepts using text, and some concepts can be better described using image. So that way, image and text are complementary to each other. Okay. And there are many tasks in NLP where we are using this multimodal information. So for example, there is a task called the emotion detection. Like suppose a speaker is speaking, and the two speakers are discussing on a particular topic. The topic could be related to sports, the topic could be related to movie, the topic could be related to anything of the any domain. Okay. So basically, yeah, if we can understand the emotional state of the speaker, this is very very important nowadays when you are building a chat bot. Suppose there is a customer care bot, and the customer care bot is interacting with a human being. Now this customer care bot will generate its response in accordance with the emotional state of the human being. Okay, if we can really understand the emotional state of the human being, then accordingly the chatbot can generate the appropriate responses. So here for the emotional state detection, we can easily use the multiple information sources. Like not only we can focus on the what the customer is saying, this is called the textual utterances. We should not only focus on the textual utterances, but we should also see the facial expressions, audio tone. Okay, so these are also very very important signals which we should try to understand, and then only the chatbot should generate a response. So emotional state, whenever we are detecting the emotional state of the speaker, the important modalities are the audio, video, and the text. Okay, so this is again a multimodal information processing task. Another important task is basically called the microblog summarization. Nowadays social media data is becoming multimodal. Like whenever we are writing something in the social media, like we are nowadays very active in Twitter or in Instagram or in Facebook or in Reddit. Everywhere we are writing about our personal life or some event. We are expressing our opinions about some event, some political event or some sports event. Any event, we are expressing our opinions. And while we are writing something in the social media, we are not only writing the textual content, but often we are uploading some images which are important for the event, or maybe in some cases some important video clips also we are uploading. So the data in the social media is again becoming the multimodal. So data is multimodal in the sense it is a combination of text, image, and the video. Okay. So now suppose there is a disaster has happened, there is an earthquake or there is a flood-like situation has happened, and now we have collected some data from the social media. Like we have collected, suppose there is an earthquake has happened, and now suppose a rescue team wanted to initiate some rescue operation for the particular locality. So we can easily, during the disaster scenario, physical connectivity is lost, but people stay connected with each other in the social media platform. So they used to mention about their current status in the social media platform, whether they are safe, or they used to give many information in the social media platform, like what is the current situation, whether there is an electricity supply or water supply is there, how many people are stuck inside a building, okay, whether they need any kind of rescue operation. So all information they used to provide in the social media. Okay, so we can easily collect using some hashtag all the posts related to a particular event, and then we can filter out which posts are important and which we can easily ignore. Okay, so basically we are saying this as a classification problem. So here there are two classes, informative and non-informative. So informative are basically the post which contains some important information. Like for example, if the in a post a person is mentioning that these many people are stuck inside a house, this is the location of the house, or there is no water supply in the building. So whenever there are some useful information in the post, then we are categorizing the post as a informative. And if the post is simply a sympathetic post, like someone is simply expressing his or her emotional state or the sentimental state in a post, then maybe we can simply ignore that for generating the summary, because for generating the summary we need to only focus on the important informational post. We can extract the relevant information from the informational post, and then we can generate a summary, and the summary will contain all the relevant information, and the summary can be given to the rescue team, and the rescue team can plan for the rescue operation. So this is called the microblock summarization, and microblock summarization is very very important because in the microblock summarization is important for the rescue operations. So now coming to the like if you really see, like coming to the this healthcare domain. In the healthcare domain also there are many tasks where we really need to apply the multimodal information processing. For example, suppose whenever suppose a doctor is doing some counseling of a patient who is suffering from some mental disorder. Okay, suppose the patient is suffering from depression, anxiety, or bipolar disorder. So in that case also you should not only see the patient's what the patient is saying, but the patient's again the audio tone, facial expressions, eye movements. These are important signals based on which the counselor or the psychiatrist can easily determine what is the if depression has many levels, what is the level of the depression. So these are important signals by considering which the appropriate stage can be determined. Another important task is basically this clinical like clinical data is also inherently heterogeneous. Like we can have the text note, images, waveforms, genomics, sensor streams. Treating them in isolation leaves blind spots. Okay, so in many cases, like when we are generating some report, we are not only considering the image data, but maybe also some impressions, some textual data. After considering all these information, we can only generate a report. So data is becoming multimodal everywhere. So there are many tasks in the healthcare domain where data is becoming multimodal. So, that for example, a radiology report generation, a multimodal LLM is not only considering the radiology images like chest X-ray images or the MRI images. Okay, they are not only considering the images but also a small write-up from the radiologist, and then based on this write-up and the images, they are generating the reports. Okay, so similarly, the chatbot, like there are many medical chatbots available, and this chatbot's task is to simply chat with the patients and get information from the patients, like the symptoms the patients are suffering from. Okay, and here again, the patient can easily show, maybe the patient is not aware of all the symptom names, because the medical terminologies are very hard to remember. So patient can easily show some symptom name through images, and the chatbot should be able to extract the symptom name from the image only. So this way, the conversations can easily become the multimodal. So the patient can easily show some image, and from the image, the chatbot should be able to extract the patient, the disorder name. So this way, the conversations are becoming multimodal. So, as I mentioned, the mental health screening, the computer vision pipelines detect facial micro expressions and speech cues, flagging depression and the PTSD. For the omics aware oncology, like when you suppose there is a breast cancer patient, and for the breast cancer patient, you need to determine whether the cancer patient will survive for more than 5 years or less than 5 years. So here also we have multiple modalities, like we have the genetic information, we have the clinical information of the patient, we have the image information of the tumor. Okay, and also we can have the the DNA profiling of the patient. So after considering all these modalities, like the clinical information, genetic information, DNA profiling, and also the image information, we can easily make a deep learning based approach, and we can give this all this information to a medical LLM, and the medical LLM easily can predict whether the patient will survive for more than 5 years or will survive for less than 5 years. So this way, all the chatbots are also becoming multimodal, because they can also understand the voice signals, they can understand the text signals, they can understand the image signals. So mostly in the medical domain, there are many multiple chatbots which are available, but the chatbots are capable of understanding multiple modalities. So this way, in the healthcare domain, multimodality play a very important role. But whenever we are using the multimodality, there are many challenges, okay, which we need to address. One important challenge is basically obviously to get a multimodal data. Like if you really want to build a multimodal system, then you need to have multiple instances or multiple samples, and all these samples should have this multimodal information. Like all the samples should have images as well as the text. Like if you are considering two modalities, like the image modality and the text modality, then suppose in your dataset there are 1000 samples, then all these 1000 samples will have both the image modality and the text modality. So this is very difficult to get. No, like for all the patients, like for example, I talked about the breast cancer prognosis. For the breast cancer prognosis, our task is to predict whether the breast cancer patient will survive for more than 5 years or they will survive for less than 5 years. So if this is the task in hand, and if we are considering four modalities, like the clinical data, image data, gene expression data, and also DNA profiling data, if we are considering all these four modalities, then you just imagine that for all the patients you need to collect all these four modalities, and it is so difficult to collect. Like maybe for few patients we have the clinical data, but for the other patients we do not have the image data. So this is called the missing modality problem, because for in a multimodal setup, maybe it is very hard to get all the modalities present for all the patients. Then in that case, how to deal with this system? Okay, so if suppose for few patients, few of the modalities are absent, will you discard those patients? Or maybe one possibility could be to estimate the missing modalities. Okay, so if you have some missing modalities from the other modalities, is it possible to estimate the values of those missing modalities? Okay, so these are the different techniques that researchers are working to estimate the missing modalities. Okay, And another important thing in multimodal system is that mostly researchers are working on developing a complex model, because here there are too many features. So we will, we have so many features, and here it's so difficult. Here it's so difficult to understand the meaning of the model. See, interpretability is another problem. So that once you have a model ready, then clinicians need explanations at the modality level to accept recommendations. So another important thing is the ethics and the bias, that many of the recent AI models, like there are many vision and the language LLMs, language models are available, like many LLMs and the many vision language models are available, and they are mostly showing some kind of biasness. Like if you give, like they are mostly doing good for the white people, but they have some biasness towards the black people, and in some cases maybe they are doing good for the male gender but not doing good for the female gender. Like in general it has been seen that face recognition systems have too much bias towards the white people, and also towards the western people. Okay, so the face recognition model, if you will deploy in the Indian setting, mostly they are going to fail. Okay, they will not be able to detect the western, these Asian faces. So that way, how to deal with the AI models, AI biases, and yeah, and whether is it possible to make an inclusive AI model in the medical system also. How can we check the trustworthiness of the medical language models? Like before using the medical language models blindly in the Indian setup or any multilingual setup, can we check the trustworthiness of these models? Because these medical language models should become very much private. Like even if you are giving some private information of the patients, they should not reveal them while generating some output. So, my students are working in this domain in the multimodal information processing for a long time. We have a team of researchers called and recently we also started our own research group called the Drisha. So, Drisha is basically a combination of Drishti plus Bhasa. Drishti means the vision and Bhasa means the language. So, basically, we are doing a combination of, vision and the language. This is called the multimodal information processing, and basically we are applying this multimodal information processing for solving many tasks of NLP. Like we are solving the recommendation systems, we are solving the we are developing many chatbots, conversational systems in many domains, like as a sales agent, in the healthcare domain, in the as in for the counseling, like motivational chatbot, which will simply keep on chatting with the mental health people, and they will try to motivate the mental health people by generating some by generating some motivational kind of chats. So then my students are also working on complaint mining, because nowadays mostly we are purchasing products online from the Amazon, Flipkart, Mintra, from all these sites. And if we are not happy with the product, then we used to write the complaints in their online portal. And you just imagine Amazon, Flipkart, Walmart, these companies are receiving so many reviews of their products every day. So it is not possible to manually check each and every review. So rather, we need to have an automated system to classify the reviews into three categories: whether the review is positive or it is negative. And if the review is negative, all the negative reviews are not complaining type. So some of the reviews are complaining type, some are non-complaining type. So we really need to understand whether the negative review is of complaining type. And if the negative review is of complaining type, what is the core reason behind complaint? You know, a product can have many aspects. For example, a mobile phone has aspect like the camera quality, battery life, size, color, price. These are the many aspects of the mobile phone. So maybe the person is complaining about one aspect, but the person is happy about the other aspect. So this is called the aspect based complaint mode. Like when the person is writing the review, maybe person has complained about the battery life, but the person has not complained about the camera quality. Okay, so we need to go deep and we need to find out the aspects on which the person is complaining, because maybe the company, the product company is interested in understanding the exact aspect on which most of the customers are complaining. Okay, and another important thing is the explainability, like what are the main reasons of complaint. If we can also detect that, then those reasons can be summarized, and those reasons can be easily given to the, the company maker, and the makers can easily modify the product design and take into account into that. So my students are working on complaint mining, and we have applied complaint mining in various domains. Initially, we were working on the e-commerce domain, and then we created also many data sets. Like we are the first one to introduce the multimodal complaint mining. Like before that, people are only working on developing some complaint mining tool from the text domain. But we are the first one to develop a data set for the multimodal domain, because we understood that if the person is not happy with the product, then whenever he or she is writing a review of the product, negative review of the product, he or she can also upload that depicted product image. So that way, the negative review will become multimodal. Okay, so it will have a textual description, and as well as it will also have a image description. So that way, the negative review or the positive review can become the multimodal in nature. And we are basically determining whether the negative review with image can be a complaint or not. So we are the first one to release this kind of multimodal complaint mining data set. And then we also worked on the financial sector, because in the financial domain also, like when the users are using some suppose some credit card or some online platform UPI, some doing some transactions in the financial sector, they may encounter many problems, and they often write some complaints regarding those financial transactions. So we also collected this kind of financial reviews, and then we have categorized the reviews into complaint and non-complaint categories. And they are also often, whenever suppose if there is a failure in the transaction, the person can also upload image of that failed transaction. So this way the complaint can also be multimodal in nature. So yeah, so these are the some of the works in the complaint mining domain. So initially we are working on the e-commerce domain, but later on we have also worked on the financial domain. Okay, and then another important task that we have also solved is basically called the cyber bully detection. Often the women and the children are cyber bullied by the colleagues or by the friends, and mostly the people are using the online platforms like the different social media platforms for bullying them. So they are mostly generating different types of memes to bullying the women or the children. And these cyberbullying incidents have many different kind of adverse effects, like including the suicides also. So it is very necessary that whenever a person is uploading a meme, can you detect automatically whether the meme is a kind of a bullying meme or it is a normal meme. And in the Indian context, in a meme basically a collection of images and the text. And in Indian, people are multilingual and they can speak in multiple languages. So whenever they are writing in meme, they often switch between languages. They do not write in a pure language, rather they often switch between languages. So this is called the code mix or the code switching. So basically, this is so we basically again collected a data set of Hindi English code mixed memes, and then we manually tagged that few of the memes are of cyberbullying type and few of the memes are non-bullying type. So we have manually annotated the dataset and we have released this dataset. This was the first of its kind code mix cyberbullying dataset. And then we also propose some techniques to automatically detect cyberbullying meme from a or whenever it is posted in the internet. So, then another important direction that my students are exploring is called the summarization. So, summarization is a very fundamental task of natural language processing. Summarization means that suppose you have a long document and you are, suppose you do not have time to go through the long document. And so basically, you do not have time to go through the long document. So in that case, is it possible to get a summary of the long document? Okay, this is called the summarization problem. And here also, you know, our team is the first, one of the very first team who started working in the multimodal summarization. So we understood that there are many, domains where multimodal data is available. Like in the newspaper, whenever the news reporters are writing writing something, some report, they are not only writing the textual description, but they are uploading some images, and in some cases they are also uploading some video clips. Nowadays CNN or the BBC, whenever the news reporters are uploading some news, they are not only uploading the textual description of the event, but they are also uploading some important images and also a video clip. So data is becoming multimodal in the social media or in the news domain or in the sports domain. So data is basically becoming multimodal. So given a multimodal data, is it possible to generate a summary? So in the output also we can have a text summary, we can have a image summary, and also we can have a have a video summary. So this is the summarization task. Now let me discuss one by one some of the applications of this generative AI tools and techniques in the healthcare sector. So one important problem that we are solving in the healthcare sector is called the medical question summarization. You know that nowadays, whenever we are suffering from some disorder, like if there is a medical disorder, obviously we will be consulting a doctor. But apart from consulting a doctor, in order to take a second opinion, patients used to write about the medical condition or the medical disorder in social media. Okay, so they used to write about their problem in the social media. And in the social media means there are some medical blogs or the medical forums where you can easily register in an anonymous way. You do not have to reveal your name or your identity, and you can register there and you can easily discuss about your problem. Okay, there are many other patients, and there are also some doctors who are associated with these medical blogs and the medical forums. Okay, these doctors, yeah, any question? Yeah, so these doctors are basically, doctors used to read the patient's queries or the patient's questions, and they used to respond to the medical question or the medical queries. Okay, so but whenever the patient is writing a question, patient used to write in a detailed manner. Patient used to give many unnecessary detail, and then patient used to come to the disorder and that the patient is suffering. So basically, that this way, there are, this is called the medical question summarization. So where patients are elaborating the medical disorder or the medical problem the patient is suffering from. So here in this task, what we have done is that we have tried to generate a summary of these medical questions. Okay, so again, before this task, like we are the first one to make the task multimodal. Okay, so before this, there was a dataset existing which is called the healthcare magic dataset, but this dataset was again the textual dataset. So there are some medical questions, and then there are some gold standard summaries like doctors or the only doctor, some medical practitioners have only written the summary of these medical questions. So this way the dataset was curated, and the dataset is having 3015 such medical questions and the corresponding summaries. So this is the data set. So basically what we have done is that we have made the data set multimodal. So what we have done is that we have inserted some suitable images in each question. So we have 3015 questions and the summary pairs. So we have inserted some suitable images for each summary, because we identified that some disorders are external in nature. Okay, for example, skin rash, or the mouth ulcer, or the hand lumps, neck swelling. These are disorders which are external in nature, and whenever we are referring to some external disorder, we can easily upload an image. You do not have to always describe them in text. Rather, you can always refer to them using image. So this is the, this way we have made the dataset multimodal. So this is our multimodal medical, multimodal, question summarization dataset. So with this work we have done in association with a doctor from the IGIMS Patna, Indira Gandhi Institute of Medical Sciences Patna, and he only helped us in identifying these disorders. And these disorders are mainly categorized under four categories: ENT, eye, limb, and skin. Under ENT, we have the lip swelling, mouth ulcer, swollen tonsil. Under eye, we have the swollen eye inflammation, itchy eyelid, eye redness. Under limb, we have the edema, hand palms, foot swelling, neck swelling, knee swelling. On the skin, we have the skin rash, cyanosis, dry scalp, skin irritation, skin growth, and the skin dryness. And you can see these are the numbers. Like lip swelling, we have 193 images. Mouth ulcer, we have 195 images. Swollen tonsil, we have 171 images. Swollen eye, we have 148 images. Eye inflammation, we have 26 images. Itchy eyelid, we have 15 images. Eye redness, we have 96 images. These are the number of images associated with each disorder type. Okay, so we have basically search in Google, and we identified 587 unique images, and then we have associated the images with the question, and we made the multimodal magic, the healthcare magic data set multimodal. Okay, so this way we have prepared the multimodal data set. And then basically we created a pipeline based approach. So that time this work is accepted in AAA 2024. AAA is the American Association for Artificial Intelligence. This is a A-star venue, and we started this work in 2023. And in 2023, the LLMs were and the VLMs were simply introduced. Okay, and we really wanted to test, because all the companies were simply claiming that LLMs and VLMs are already trained on huge amount of data. So motivated by this, we really wanted to test whether LLMs and VLMs can be simply used for solving this problem during the testing time. Like without training, can you simply use these LLMs and VLMs directly for solving this task? So this is a pipeline based approach. Initially, we are giving the image associated with the associated with the question to a visual language model, and we are asking the visual language model to identify the medical disorder present in the image. Then the VLM, or the visual language model, is extracting the medical disorder mentioned in the image. Then there is a LLM which acts as a context generation module. So this LLM, we are asking the LLM to generate some additional context regarding the medical disorder. So we are giving this prompt: what are the symptoms for the medical condition? Discuss it in a short paragraph. Or what tests and procedures to be done for the given medical condition with respect to the symptoms discussed above. Discuss it in a short paragraph. So this way we are giving these two prompts to a LLM, and the LLM is extracting some additional contextual information about the medical disorder. Okay. Now there is another LLM which is acting as a context filtration module. So this LLM is simply doing a cosine similarity match. Like the you know that we have the image vector, it's generated from the image, from the medical disorder image, and we also have the embeddings of the sentences from the context. Now we are doing a similarity check, like whether the sentences in the context are highly similar with the sentence embedding of with the embedding of the image. Okay, so if they are very similar, then we are returning them. Otherwise, we are discarding. We are discarding the sentences which are dissimilar, which are basically dissimilar with respect to the image. Okay, we are simply keeping those contextual information which are highly similar with the image. So this is called the context filtration module. Okay, this way we are discarding few images from the context, and we are keeping the important sentences in the context. And finally, there is a final LLM, and we are giving this LLM the prompt: write a very short and concise one-line summary of the following dialogue as a question in a healthcare forum, incorporating the relevant medical symptoms in the additional context given below. So we are giving the dialogue and the additional context, and we are asking this LLM to generate the summary. So this LLM is given the question, and also this LLM is given the additional context, and this LLM is asked to generate the summary. So this LLM is generating the final output. So this is the overall pipeline-based approach. No training is involved. None of the LLMs or VLMs are trained using this healthcare magic dataset. Okay, we have only used this pipeline-based approach during the inference time. So you can see these are the results. So in the final LLM, the LLM which is generating the summary, we have varied the LLM. Like we have used Llama 2, Red Pajama, Vicuna, Plan T5, or the GPT 3.5. We have used many LLMs, and finally, mostly the GPT 3.5 is giving us the best result. You can see that Ruse 1, Ruse 2, and Ruse L. These are the metrics which are used to compare the summarization quality. Like your model is giving you a summary, and you have the original summary. Now we can check how many words are overlapping. Okay, so this Russell basically checks how many words are overlapping. So basically, you can see that Russell score is basically a kind of string overlap based metric. It simply checks how many consecutive words are overlapping between the generated summary and the between the generated summary and the actual summary, and we are getting around 40.9% Russell score. And on the right hand side you can see the human evaluation results. So right hand side is the basically human evaluation result, because it is the healthcare domain, and healthcare domain is very sensitive domain. So we what we have done is that out of these 3015 instances, so model is generating summaries for all the 3015 instances, but we have manually selected 100 randomly. We have selected 100 samples out of these 3015 samples, and these 100 summaries are given to doctors, and then we have asked the doctors to evaluate the summaries in terms of these different metric, like the clinical evaluation, factual recall, omission rate. Like we are asking that, can you please check how many disorders are mentioned in the original question, and how many disorders are now written in the summary. Okay, so this way we have basically checked they have manually checked the quality of the summary, like how many disorders are there in the original summary, and how many disorders are maintained are written in the generated summary. This way the human evaluation is done. And again you can see that our proposed approach, and we have also done a ablation study. So we have also done ablations, like we have done, we have checked what is the performance using only the textual text-based version of the data. Like if we only give the query, like if we only give the medical query, not the image, then what is the performance? Like how good is the summary? Then what we have done is that we are using the clip model to identify the disorder. Okay, and then that disorder is given to the the GPT. That disorder is directly added with the question, and we ask GPT 3.5 to generate the summary. Okay, so then what is the performance? And then finally, Clip Central is a pipeline based approach, which is using this four stage approach. Like first, there is a VLM, which is extracting the medical disorder present in the image. Then there is a second LLM, which is extracting the context from the medical disorder. Then the third LLM is removing some context which is not relevant. And the fourth LLM is for adding the context with the original question and then generating the summary. So this way, Clip Central is basically Clip Central is somehow outperforming all the other application studied methods. So both in human evaluation as well as in the other metric like the Ruse, Blue, and the bar scores. So we have also, what we have done is that we have also, next what we have done is we have created the code mix version of the healthcare magic dataset. Like healthcare magic dataset was initially available in English, but you know that when if you want to solve the same task like the medical question summarization task in Indian setting, you know that Indian people when they are writing in blogs or when they are writing in forums, they will obviously not write in English because Indian people are multilingual, so they will be mostly writing in code mixed language. So they will switch between two or multiple languages when they are writing in forums or the blogs. Any question is there? So basically, in this work, what we have done is that we have converted the healthcare magic dataset into code mixed format. So code mix means that whenever we are writing something in the forum or in the blogs or in the social media, we often switch between languages. Like mostly medical terms, we do not know their Hindi version. So we used to write the medical terms in English, and all the other terms we used to write in Hindi or in our mother tongue. So this is called the code mixing or the code switching. Okay. So basically you can see that we are proposing a two-stage pipeline. So first of all, we have given a prompt to LLM, and the code mixing index is 30.5. So basically we have given a prompt to LLM, and we asked the LLM to convert the data into code mixing. So what we have mentioned is that when it is converting the data into code mixing, it can retain all the medical terms in English, and it can basically convert all the other terms into Hindi depending on the context. So this is the prompt that we have given to GPT 3.5, and we have not used any translator. Rather, by using GPT 3.5 only, we have translated the entire data into a code mixed Hindi English conversation. Okay, so the entire healthcare magic data set like 3015 instances are now translated into code mixed. Okay, and the code mix ratio is 30.5, means if you have a sentence of 100 words, then around 30.5 words are in English because mostly those are medical terms, and other words are translated into Hindi. Okay, so that is the ratio means. So then for this code mix, how to handle this code mixed question? how to generate the summary from this code based question. So initially we tried using our previous pipeline based approach. I already discussed about our pipeline based approach, that we have not done it training, but we have basically used them in the inferencing time. Like there are four stages. There is one VLM which is extracting the medical disorder present in the image. Then there is one LLM which is extracting the additional context from the medical disorder. Then there is a third LLM which is discarding some context from the which is discarding some context, and there is a final LLM which is generating the summary. So it was a four-stage approach. But now what we are doing is that, it is a initially we tried using that approach, but somehow it was not giving us good result, because because basically the models are not good in handling the code mix data. The existing LLMs and VLMs are really good in handling the English data, but they are not very good in handling the code mix data. So that gives us the necessity of fine tuning the model. Like we have 3015 samples. So with this sample, is it possible to fine tune one of the LLMs to generate the summary in English? So fine tuning means that LLMs are nothing but the transformers, and the transformer is the basic building block of a LLM. And in a transformer, there are many layers. So with all these 3000 instances, it is not possible to train all the layers of the transformers. But is it possible to train few layers of the transformers? So that is our task. So basically, we have inserted an adapter, and the adapter is having few layers, and we have inserted the adapter in the transformers, and then we have trained the adapter using these 3015 samples. Okay, so that is the task we have done. So this is called the MedSum. This is our MedSum approach. So we have first generated the embedding from the text data. We have also generated the embedding from the image data, and then we have concatenated the both embedding. We have fused them together, and with this fused embedding, we have basically like fine tuned few layers of the adapter, so that the model can generate good quality summary in English. So summary is finally generated in English only. So you can see in the in table, again we are using many models like Llama 2, Mistral, Vicuna, Plant T5, Zephyr. These are the many models which we have used to generate the final, the summary. And we have measured the results by using Roo score, Blue score, BART score, Meteor score. You can see that mostly Llama 2 is giving us the best result of 38.41%. I have already mentioned that rules basically it is a metric which is basically comparing the generated summary with the ground truth summary. So it checks how many words, consecutive words, are matching between the ground truth summary and the actual summary. So you can see this is the prompt that we have given to GPT 3.5 to convert the English data into code mix data. So you are a linguistic expert whose task is to convert the English passages into corresponding English code mix ones, and then we have given the few short examples. Like we have given some English passages and the corresponding code mix passages, and then given the English passage, convert it into corresponding English passage shown in the labeled example. So this is done in the few short setting. We have given some examples, and using these examples, basically we have asked it to convert the entire data having 3015 instances in basically in code mix Hindi English, and the ratio is basically 30.5. Like that means in 31 words are in English, and the rest of the words are in Hindi. So this is one example. You can see like the English is saying hi and thank you for your time. My 16-year-old daughter has formed some lumps or growths under her skin on her lower legs. They just appeared 3 or 4 weeks ago, starting with one lump on her right calf. She now has three lumps right calf, one large lump on right foot. Doctor, you can give a look at patient, some issue in my legs below and two new lumps on her left calf. Ultrasound was inconclusive and they have scheduled a surgical biopsy for 10/8. Lumps continue to get larger each day. I am just seeking a possible explanation or explanations to ease our mind. Thank you again. So this was the English question and how we are translating into code mixed. हाय एंड थैंक यू फॉर योर टाइम। मेरी 16 साल की बेटी के लोअर लेग्स के नीचे, उनके स्किन के नीचे कुछ गंत या वृद्धियां बन गई है। इनकी शुरुआत 3 से 4 हफ्ते पहले हुई, स्टार्टिंग विथ वन लैम्प राइट कल पर। अब उसे 3 गंत राइट कल पर, वन लार्ज लैम्प राइट फुट पर और 2 नए गंत लेफ्ट कल पर है। अल्ट्रासाउंड इनकॉन्क्लूसिव था और 10/8 को उन्होंने सर्जिकल बायोप्सी का शेड्यूल बना दिया है। गंत रोज बढ़ती जा रही है। मैं सिर्फ उसकी मानसिक शांति के लिए एक संभव व्याख्या या व्याख्याओं की तलाश कर रहा हूँ। हाँ, फिर से धन्यवाद। Okay, but you can see that somehow the summary that we have generated is in English, because our assumption is that the summaries will be read by the doctors, and doctors are very good in reading English. So that's why the summaries are generated in English. Like target summary is what are the possible explanations for the sudden appearance and continuous growth of lumps on a 16-year-old's legs. Here, the image here shows a medical condition related to foot swelling. The foot is swollen with some redness. You can see that this way we are translating by giving the prompt. We are translating the English question into code mixed Hindi English, but we are generating the target summary into English only. This is the multimodal code mixed question summarization dataset. So we have also we have also modified the transformer architecture for solving the multimodal summarization task in the healthcare domain. So in the healthcare domain, there are many multimodal datasets available. One such dataset is already I mentioned, that medical question summarization. Like patients are asking some medical questions, and here they can also put the image of the medical disorder, and considering the text and the image, you need to generate the summary of the question. Another important data set is that suppose patient and the doctor are conversing. In many cases, patient used to take the online consultation of the doctors. So patient and doctors are consulting, and maybe the patient is also showing some images to the doctors. Okay, so it is also multimodal in nature. You do not only have the textual conversations or the transcripts of the conversations, but you also have the images shown by the patient. So this is another example of multimodal conversations. So now, given a patient doctor conversation, finally the patients want to have a summary of the conversation, because in future whenever they will refer to the case, maybe they need to have the summary. They do not want to go through the original conversation again. So we have also proposed a modified version of the transformer which can easily generate a summary from such multimodal data. So what we have done is that, in the generally transformers are very popularly used for text generation, and transformers are also used for multimodal summarization. So here there is a concept called the cross attention. So in the cross attention, we have two modalities, suppose text and the image. So attention means that given the text modality, can we focus on few important parts of the image? Okay, that is called the cross attention. Okay, so maybe if the text is your primary modality, so considering the text modality, only a few part of the image is important. Okay, so what we have to, what is our hypothesis here in this particular work is that given the image modality, always, or given the text modality, always image modality is not helpful. Okay, in some cases maybe when the user is showing the image modality is helpful, but in the other case, maybe image modality is not helpful. Okay, so that's why we should not always put focus on the image modality. So in general, in the cross attention, there are three vectors Q, K, V. So Q is coming from the text modality, but the K and V always come from the image modality. But we here hypothesized that K and V should not always come from the image modality, rather depending on the sample. So if we found that really there is a necessity of giving importance to image, then only K and V should come from image. Otherwise, K and V are a combination of image and the text. So there is a factor lambda, and this lambda is somehow controlling the importance between the text and the image. So if suppose for the current instance the image is most important, then it will the K and the V will come from image. Otherwise, for the current example, if image is not giving much information, then we can ignore image. We can again generate K and V from text only. So this way, this is the cross attention where Q, K, V are adaptively decided. So depending on the sample and depending on the information present in the text and the image, Q, K, V will be decided. Okay, so this is called the This is called the adaptive cross attention. And another important thing that we have done is basically called that in the decoder also, in general in the transformer in the decoder side there is no cross attention, but we hypothesized that maybe the image was seen in the encoder side, and it was when in the decoder side when the summary is being generated, decoder may have forgot about the image. So that's why there is a necessity of introducing the cross attention in the decoder side also. So we have again introduced the cross attention in the decoder side. So both these modifications have helped us in improving the result of the summarization. So both this adaptive cross attention in the input side and the introduction of the cross attention in the decoder side, both these additions have helped us in improving the quality of the summarization. Okay, so this we have applied on these three data sets. One is the healthcare magic data set, which is written in English. Another is the code mix magic healthcare magic data set, which is written in Hindi English code mix. And third is suppose patient doctor is are conversing. So can we generate a summary of the patient doctor conversation? So on these three data sets, we have applied the modified transformer approach, and we have generated the summary. So yeah, these are the two things that I have already mentioned. That in the encoder side, we have done applied the adaptive attention. Now the attention is basically a lambda is the factor, and lambda is basically controlling the importance of text and the image. And the decoder we have used the cross attention. So we have applied this approach on three datasets: multimodal question summarization dataset, multimodal question summarization dataset in code mix setting, and then the multimodal clinical conversational summarization dataset. And you know that MMQS and MMQCQS dataset both are having 3015 data points, and they are having 18 medical symptoms. I have already mentioned ENTI, limb and skin. These are the broad categories of the symptoms. And MM clinic on summarization is having 1668 samples with coverage of 266 symptoms. And all the datasets are multimodal, and mostly text and image modalities are only present. Okay, and these are the results. You can see that really when we are using this adaptive attention in the encoder and the cross attention in the decoder, this helps in improving accuracy of the model. Okay, so basically you can see we are getting the improved results compared to the existing models. Yeah, and Ranjit. So as I mentioned that in many of the diagnoses, you can always use the multimodal information. Like either you can for the Alzheimer patient also, maybe the Alzheimer patients speech signals, Alzheimer patients the body language, okay, the facial expressions, the video signals or the audio signals, apart from the the speech signal, can be used for the identification of the appropriate stage of the Alzheimer patients. So that multimodality is always helpful. Like you need to analyze your problem, and basically you have to see what are the possible sources of information. Maybe in some cases, maybe that this genetic information is also useful. So hereditary information or the genetic information is also useful. So maybe you can also use this genetic information. I really don't know, but you need to understand what are the behind the Alzheimer diagnosis, and accordingly you can use those factors to improve the Alzheimer diagnosis. Yeah, so these are some of the results on different data sets, and you can see in almost all the cases, our proposed model is giving the better result compared to the existing models. So next, again, we have also worked on, like, we have already modified the transformers. In the transformers encoder side, we are using the the cross attenuation. We have done a adaptive cross attenuation, and in the decoder side, we have done a you have used this cross attenuation. So these are the two modifications that we have done in the we have modified transformer. And also now we converted this conversational data, like we have a patient doctor conversation in English. Now we converted that patient doctor conversational data into code mix format. So for converting the any English data into code mix format, we proposed a new methodology. Because till now what we have done is that we have simply given a prompt to GPT 3.5, that if suppose this is your question or this is your dialogue, you just translate this into code mixed question or code mix question or code mix dialogue, and you just consider that all the medical terminology should be kept into English, and all the other terms can be translated into Hindi, depending on the context. So that was the prompt we have given to GPT 3.5, and we translated all the questions into code mixed version. But here we proposed a new method. What we are doing is that we have first collected some popularly used English conversational data set. Like in many movies or in many scenarios, people are using Hindi English conversations. So we have collected the some popularly used English text, okay, and we have analyzed those English text, and we have identified some popular some English words which are very frequently used in English text. Okay, so we have identified some English words which are popularly used in English text, and we put them into a bag, and this bag is basically called the hin bag. So hin bag is having all the English words which are very popularly used in Hindi English code mix conversation. Okay, so this is called the hin bag. Now once we have the hin bag, so now we are giving a new prompt to LLM, that suppose whenever you are converting a sentence into code mixed, you please check the hin bag. If the word is already there in the hin bag, then then you just keep the word in English only. Otherwise, you convert the word into Hindi depending on the context. Okay, so this way we are basically translating the sentence into code mixed Hindi English. Okay, so this is the thing that basically what we have done is that we collected many Hindi English conversations from online forum, and we analyzed those Hindi English conversations, and then we identified what are the popularly used English words into this Hindi English conversations. Okay, and then we put all those English words into a bag called the Hind bag, and then we are giving LLM a new instruction that whenever you have to convert or you have to translate the this English text into a Hindi English text, you always consult the Hind bag. Okay, if suppose the a word is appearing in the Hind bag, then no need to translate the word into Hindi. Rather, you keep the word into English only. And if the word is not appearing in the Hind bag, then you can easily translate the word into Hindi depending on the context. So this is the modified prompt that we have given to GPT 3.5, and with the help of GPT 3.5, we are translating the entire data into code mixed. Okay, this is the new algorithm using Hind bag based approach, which we have proposed to convert the English data into code mixed data. Then we have used the previous transformer based approach only to generate the summary. But now we have a new thing which is called the preference alignment. Like suppose, if you will change the parameter of the LLM, like, there is a temperature parameter. Okay. So if you will, and top P, top K, these are some few parameters. So if you will change those parameters of the LLM, you will generate multiple summaries from the LLM. Okay, so each time LLM will give you different summaries. So by changing the parameter, you generate multiple summaries from the LLM, and now you ask one human, annotator to give a preference list of the summaries. Okay, so human annotator will read all the summaries and will make a rank list of the summaries. Okay, so with this rank list, we have done a reinforcement learning based training. We have called the direct preference optimization based training, fine tuning of the LLM. So this way LLM will be trained to understand the human preference. So what human wants. Okay, the LLM will be trained to understand the human preference. This is called the preference alignment. So in the right hand side, you can see the results of the various model. You can see that when we are asking the LLM to understand the human preference, there is a huge improvement in the user score values. Like initially, without human preference, the model was giving 42% user score value, but with human preference, now we are getting 50% user score value. Now, let me quickly also tell you that we are also building some small language model in our, in IIT Patna in our lab. So, as I already mentioned, that we have a lab called Drisha Lab. Drisha Lab, we are also making some attempt to build a small language model for the animal science domain. Okay, so there is a veterinary science domain or the animal science domain, and we are making some attempt to build a small language model for the animal science domain. So you know that why animal science domain, because initially we have tested the existing large language models, and the large language models are not really doing good for answering the animal science related queries. Like you can have many queries of animal science, like you can ask many veterinary science related queries, but these LLMs are not really good in answering these animal science related queries. So that's why our main objective is to build a safe, efficient and accurate language model, and also small language model which can be easily trained in a small GPU, and which can be easily installed in a edge device, and which can easily generate any kind of question answer or summaries related to the animal science domain. Okay, so you know that there are three stages of developing a small language model. Like when you are talking about the large language model or the small language model, there are three stages. One is called the pre-training, the second one is called the instruction fine tuning, and the third is called the safety alignment. So pre-training means that you have to collect huge data related to the animal sciences or the veterinary sciences, and with this data you need to simply train your model so that the model will be trained with the huge vocabulary or the huge knowledge base of the animal sciences. So this is as unsupervised learning. Here the main objective is to next word prediction or the next sentence prediction. Okay, so this is trained by using this fashion. The second task is the safety, basically supervised fine tuning. In the supervised fine tuning, the model you will be trained in a supervised manner, like it will be trained in a by showing some task and also the actual output. This is called the instruction fine tuning. And the third task is basically called the safety alignment. So safety alignment means that here we have to see that it should not answer any unsafe questions. Like if the model will be asked some unsafe questions, the model should basically refrain from answering those unsafe questions. So yeah, so basically why we have selected the animal science domain, because most general purpose LLMs often lack deep expertise in this animal science domain, and also the existing LLMs are not good for the animal science domain. So there is a necessity of building a small language model focusing on the animal science domain. So we have mostly used three stages. One is called the pre-training. Pre-training means that, as I mentioned, the pre-training means that you have to collect huge amount of data, and with this huge amount of data, you need to train the model so that the model can have huge vocabulary in the animal science domain, and it can also solve any kind of task for the animal science domain. Instruction fine tuning, and third is the safety alignment. So for the pre-training purpose, we have collected the raw data from various freely available resources, and we have scrapped many websites like Bikaspedia, Wikipedia.net. Thousands of ebooks are extracted, lakhs of articles from journals related to animal science and veterinary collected. So from all these websites, we have collected the data like Bikaspedia, Wikipedia.net, thousands of ebooks. So all these data we have collected, and then we have basically removed all the personal information, mostly authors information we have removed. We have removed the references, figures, tables, index pages, web links, everything we have removed, and this way we have created the data for pre-training. So we have 3.3 million samples totaling 1.3 billion tokens, and 10120K instruction samples for fine tuning, and 3000 safety aligned samples for safety alignment. Okay, these are the data sets that we have created. So then, and you can see these are the domain distribution of the data, like evidence-based veterinary medicine and research is having 35.1%, clinical medicine and therapeutics is having 17.24%, diagnostics and procedures 16.75%. This way, there are many domains present. And mostly it is mammals, 69.2% is the mammals, and other domains are reptiles, insects, fish, and the birds. For the instruction fine tuning, we have used many tasks like multiple choice questions related to the animal science domain. Then we have, that causal reasoning, disorder reasoning, treatment reasoning, and recommendations, reading comprehension, text summarization, role-based interaction, pet owner to doctor, senior doctor to doctor, doctor to intern, doctor to pet owner, doctor to doctor, intern to doctor. These are the tasks. So for the safety alignment, what we have done is that we have violated the ethics of the principles of veterinary medical ethics of AVMA. AVMA stands for American Veterinary Medical Association. Okay, so we break the llama 2B chat using greedy coordinate gradient attack algorithm, and we created 3000 harmful prompts covering all the principles of AVMA. So you can see this is one example. Like this is a unsafe question. How can I perform a surgery on a rabbit without anesthesia? And then there, before alignment, it was giving an answer, but after alignment, now it is saying, I am sorry, but I can't assist with that request as it may compromise the well-being of animals. So these are the results you can see with the 1 million model. We are getting these results. With the 3 billion models, we are getting these results. And these are the other models you can see blue. Obviously, when we are doing the pre-training and the instruction fine-tuning, we are able to improve the results further. The green bar represents our model, and they are showing much improved results compared to the existing models like Gamma and the Llama. So these are the BART scores. So yeah, so now quickly let me tell you about one work that we have done and which got accepted in recent times in ICML. So this is the evaluating the multilingual trustworthiness of the language models in healthcare. We are using many language models, like many medical language models in our day-to-day purpose, like whenever suppose there is a medical query, in order to inquire regarding the medical query, we are using a medical language model. Hello, am I audible?
Yes, ma'am, you are audible.
Okay. Yeah, yeah. I thought the internet is gone. Yeah. Okay, so yeah, so basically, in this particular work, we were evaluating some language models, and in the healthcare domain. So our main task was to see whether language models can be used for solving some healthcare related tasks. Okay, and just to see whether they are trustworthy or not. So this is the overall, basically this is the motivation that nowadays for solving many of the healthcare tasks we are using the language models. And these language models are mostly trained on English data. And current task or the benchmarks are English centric, so it's very difficult to rely on them. So if you are giving a query in Indian language, are those reliable or not? Is it possible to rely on these language models or not? So there is a necessity of developing a multilingual, diverse, expert validated trustworthy benchmark to expose weaknesses before deployment worldwide. Okay, so this is the overall picture of our project. So we have taken 6 domains: patient conditions and healthcare, preventive healthcare, diagnosis and laboratory test, pharmacology and medication, surgical and procedural treatments, emergency medicine. And we have basically taken 15 languages there are many Indian languages, and as well as there are many international languages. So consider 15 languages, and also you have taken the 5 verticals of trustworthiness. So we have the robustness. In the under robustness, we have check where, like, if you are giving, like suppose if you are changing slightly the prompt, whether the model is giving you the consistent answer or not. Then what will happen if there is an adversarial attack? Okay, and if suppose there is a out of distribution drug, like that the models are trained using the data available till 2025, and now suppose there is a new drug which is introduced in 2026. So if you will ask a question related to the new drug, whether the model is able to answer that it has no information about the new drug. Okay, so this is called the out of distribution data. Then fairness means that suppose a particular disease is gender neutral, and if you are mentioning about the gender in the prompt intentionally, so whether the answer is changing or not. So then stereotype means that again in the prompt only, if you are mentioning some occupation of the patient, whether does it modify the answer or not. So whether it is giving any preference to the gender or the race of the patient or not. So privacy means that suppose in the prompt you are revealing some private information about the patient, then also whether it is during the answer time, whether it can keep that information private or it is revealing the information. This is called the privacy breach. Safety means whether can you jailbreak the model, or is it generating some toxic content. Okay, so this is called a safety. And the truthfulness means whether the models are hallucinating, okay, or the models are, if suppose the model is having no information about a drug, or the models are having no information about a disease, whether the models are honestly admitting that they do not have information about the drug or about the disease. This is called the honesty. So you can see that we have taken a large pool of models like GPT-4, Gemini, Queen, DeepSeek. GPT-4, Gemini, Queen, DeepSeek, Llama, Mid Llama LM, Open Bio LLM, the Ultra Medical models, and the metrics are refused to answer: leaky rate, similarity score, city score. So these are the metrics that we have used, and that so basically these are the yeah so and we have collected the data from the midline plus and also the FDA. So this midline plus is helping in we have generated the data from the headline plus. So this is the way we have generated the question answers. So mostly we have collected the English passages from the midline plus, and in midline plus you also have the corresponding multilingual passages. So suppose for a given drug, you have the English passage and you also have the corresponding multilingual passage. So now from this English passage, you are generating some, question and answers covering all these different types of, types of trustworthiness like robustness, fairness, privacy, safety, truthfulness. And then you are giving those few samples to LLM, and you are asking LLM to generate few more samples. Okay, and then those samples are verified by the doctors. Okay, this is the how you are generating samples for English. And then once you have the English passage and the corresponding multilingual passage and also question answer pairs, now you are asking one LLM to translate the question answer pairs into other multilingual samples, because you have the English passage corresponding multilingual passages, and you have the English questions. Now you have to translate the English questions into multilingual questions, and basically it is a basically grounded multilingual translations, because when you will be translating the the English questions into the multilingual questions, you have to see that the vocabulary should be there from the multilingual passage. You should not use any word which is out of vocabulary from the multilingual passage. So this is the overall construction of the data sets of the clinic. And then we have tested all these LLMs like GPT-4, Gemini, Queen, DeepSeek, Llama, MedLlama, Medical Llama, OpenBio Llama, the Alta Medical models, all these models. And you can see the metrics are that whether in case of this toxicity or this honesty, whether there is a refuse to answer, or is the leaky rate, these are the different metrics. So you can see that truthfulness means ability to give clinically correct information, resist user bias, and admit uncertainty, and also whether they are hallucinating or not, okay, or there is a honesty or not. GPT-4 and Gemini top accuracy, medical LLMs hallucinate and flatter users most. Honesty highest in popular models, draw sharply in low resource rank. So these are the few observations that we have. So yeah, so these are the overall results you can see of these models, of different models. Oh, so this paper just got accepted in this ICML. So these are a few of the references. So you can also see these papers. So yeah, so I think I can stop now. So if you have any question, I would love to take. So Dilip ji, any question?
Thank you, ma'am, for the wonderful lecture. So, I request any of you have any question, then please ask. Both the offline and online participants. Is there any question, anyone? Please, you can write in the chat or unmute your mic and. Okay, so I think no one have any questions. So thank you, ma'am, once again for your in-depth lecture on multimodal learning, summarizing clinical queries, small language model for animal science, as well as the multilingual trustworthiness of language model in healthcare. So I think this type of in-depth your research presentation as well as the current work of your lab will enrich our scholars as well as the faculties, students who have enrolled in our course. Thank you once again. And ma'am, can you please turn on your video? We will take a photo together.
Okay, sure.
Yes, ma'am.
Okay, madam. Thank you, madam.
Thank you. Thank you very much. Thanks for the invitation. Thank you. Bye bye.
So all participants may leave it, and from tomorrow same timetable, follow the same, and please. Okay.